Hello, geometry students. We're going to start algebraic proofs, just to kind of get us in the groove of writing proof, what it's all about. And we're going to use properties of equalities to do so. So an algebraic proof is pretty much what we're going to solve an algebraic problem using algebraic statements, obviously, and just providing justification using those properties of equality. So I'll show you what it looks like. But first we need to know what are these properties of equality. So I want you to pause the video and write these down, and then I'll show you some examples. Alright, so subtraction property would be if we had like x plus 3 equals 6 and subtract 3 from both sides. That'd be the subtraction property. If a equals b, then a times c equals b times c. So let's say we started out with x over 4 equals 2. I could times by 4 on this side. I got times by 4 on this side. A equals b if we divide by c on both sides. So if we had 4x equals 16, we could divide by 4 on both sides. That would be the division property. Reflexive property, a equals a. So if we had, for example, if we ended up with an equation that was like 3 equals 3 or x equals x. Symmetric property, let's say we had 3 equals x and we want to switch it over to x equals 3. That'd be the symmetric property. Transitive property, this one, let's say I had like triangle equals circle and circle equals square. Then we could say triangle equals square. That's what I could come up with off the top of my head. Substitution property, if a equals b, then a may be replaced by b in any equation or expression. So if I said like 3 times 2, I could say that equals 6. I could substitute it with 6. And then the distributive property, if we had 3 times x plus 2, it would equal, if we distributed 3 times x plus 3 times 2. And one property that's not on here that we could need to add to the list is the addition property of equality. If we could add a value to both sides, so if we had like x minus 2 equals 5, we could add 2 to both sides, and that would still be legal. So those are the properties of equality. So what we're going to do now is actually write an algebraic proof. And what we're going to do is prove that if a negative 5 times the quantity x plus 4 equals 70, then x equals a negative 18. We have to prove this. So we're going to start here, and we're going to end here. So we're going to make a T-chart to kind of just organize our reasons and statements. Reasons are going to be our justification. So we're justifying why can we do this. So we're going to go ahead and start out with our problem. And so that is given to us. So then the next step, think about what you would do to solve for x. I would distribute. So we're going to go ahead and distribute. So we have a negative 5x plus it'd be a negative 20 equals 70. So the distributive property of equality. And if you want to abbreviate, go right ahead. Oops, I want to say property of equality. Okay. So now what would we do? Well, we would add 20 to both sides, because plus and negative, isn't that like subtraction? And what property is that if we're going to add 20 to both sides? It'd be the addition property of equality. So we have a negative 5x equals, that'd be 90. So now think about your next step. Right, we divide by negative 5 on both sides. So when we divide by negative 5, that's the division property, we get x equals negative 18. And there you go. That's where we want to end up. All right. So this is where we started. That was given. And all we did was just solve it. And then we just justified why we could do that. So that's the big thing in geometry, is we have to justify every step that we do. We can't just make stuff up. We can't just say, oh, because we have to have reasons to do so. So that's an algebraic proof. And that's all I have for you, and you guys have a wonderful day.